Okay, so let's do a few more problems from section 9.5. First, I'd like to look at number 15. Now, number 15 is, again, one of these problems like the previous video. So it's a nice warm-up problem. So we have 2 sine theta equals -1. Again, we're dealing with this restriction of being in one full rotation. So within one rotation, what do I do? Again, I'm going to solve for sine theta, so I'm going to divide by 2. And I'll get sine theta is -1/2. And so if I look at my unit circle again, I'm looking for places where the SIN, the sign, is -1/2. Well, I do know that at pi over 6, I will have a sign of 1/2, positive 1/2. So moving vertical from that point will change the SIGN sign of that point from positive 1/2 to -1/2. So I get root 3 over 2 -1/2. And I'd like to say that that's negative pi over 6. And if I was doing something with an inverse trig function, that's what I would say. But the problem is I can't do that here because they're telling us, well, we need theta that you tell us to be between 0 and 2 pi. That is, in other words, all these things need to be in one full row positive rotation. We're not allowing negative theta values here. Now, we did earlier, but now we don't, and that's, again, because of this restriction. So we don't want to call it negative pi over 6. It's correct, but for the instructions that we have, that's not what we want, okay? So instead, what you have to do is you have to count out 1 pi over 6, 2, 3, 4, 5, 6 pi over 6 is pi, 7, 8, 9, 10, 11 pi over 6. Or in other words, it's 1 fewer than 12 pi over 6. Now, again, we're looking for y values of -1/2. So if I move in the x direction here to this point, then I have not changed my y value. I've not changed my vertical height. And so I get this point as well on this, on this picture. And it's the only difference between this point is that its x-coordinate is negative because I went across the y-axis to get there. And due to the symmetry of the circle and how nice it is, it's going to be the exact same distance, just with a minus sign. So we get 7 pi over 6 out of this. Again, I can count it. 1, 2, 3, 4, 5, 6 pi over 6 is pi. 7 pi over 6 is right there. And that's it. There are no other places with a y value of -1/2, right? Because all those places would lie on this red line. And there's only 2. And so we found all of them. It's a very geometric kind of understanding here. I mean, you can see that there's only 2. There are no others. But we can't report this as negative pi over 6, again, because of this artificial restriction. If we started letting negatives in, then yeah, that could also be a solution. But as I said earlier in a previous video, there's really infinitely many solutions to this. It's just that we need to specify which ones we care about in which situations. So there are branches of math that don't like 0 to 2 pi. Instead, they prefer minus pi to pi. Or maybe they'll put the or equal to there. There's other branches of math that do this. And that would mean you're allowing a negative in this direction and a positive in this direction. You still don't overcount, but again, it's one of these things that you have to agree in advance where you're going to have solutions. And your job as a student is to pay attention to what you're being asked to do. So that's 15. Now, these problems can go on like this forever, but there's a little hitch we can throw in it with number 18. Now, number 18 asks you to solve 2 sine of 2 theta is square root 3. Now, it's tempting It's tempting to use the double angle identity we had to say, well, 2 sine theta is 2 sine theta cosine theta. It's very tempting to do that. But the problem is that's not going to help you. One way to make a mistake, let me put it in red. This is a mistake. An easy mistake that's common to make would be to say, well, sine of 2 theta is 2 sine theta cosine theta. I already have a 2 there. So, 2 sine of 2 theta, which is what I have over here, is 4 sine theta cosine theta equals root 3. And then divide by 4 and say, well, okay, sine theta cosine theta is root 3 over 4. And then people are, for some reason, they will say, okay, I can split that up to say sine theta is root 3 over 4, cosine theta is root 3 over 4, and then somehow solve that. That is not correct. What you're making a mistake doing there is what's called the zero product property of the real numbers, and it says if I had, it would say correctly, if I had two things multiplying to 0, then I can say one of them is 0 or the other one is 0. But that's special property of having 0 over here, okay? And we don't have 0 over there. We have root 3 over 4 over there if you had done this. So this is not the way to do it. So get that out of your mind immediately. It will not help you. So instead, what you've got to do is you've got to rely on what we've already done. And that involves unit circles. So I'm going to solve this thing, again, for sine of 2 theta. We do not have a property that would say let the 2 come out of there somehow. We don't have such a thing. The closest thing we do have is this, and we just saw that that doesn't really work. So there's not a special property we can use. Sine of 2 theta is not the same as 2 sine theta. If it was, then the sine function probably would not be wiggly, for example. So we're stuck. This thing is stuck in there. Okay, there's not a thing we can do about it. It's stuck. Well, what we do instead is we say, okay, I can accept that that's called 2 theta. I'm just going to give it another symbol. I'm going to call it psi. Okay, and if I let psi be 2 theta, I can actually solve the thing, right? I can solve it the way we had just solved the previous problem. So if I call this thing a new symbol, okay, it's this thing in mathematics, we're giving something a new name, opens new opportunities for us. It gives us the ability to do things we couldn't have otherwise feel like we could have done. So we now have this equation. If we use this thing's new name, we get this equation. But we can solve this. We know on the unit circle, root 3 over 2 for a value of sine occurs at pi over 3, right? Because the coordinates here at pi over 3 and here at 2 pi over 3 has a negative on the x, sure, but the y value is the same. These two things are the solutions to this. So we can say, just like before, well, psi is root 3 over 2, and psi is, sorry, not root 3 over 2, it's the angle. So it's pi over 3 and 2 pi over 3. Well, we can almost do that. This is where the fact that there's infinitely many solutions actually comes into play. These are solutions, but we need to consider others. We're in fact going to get more than 2 solutions to the original problem. And that has to do with the fact that what was previously one trip around this circle, when I put that 2 in there, it sort of doubles the travel time. So when theta is going from 0 to 2 pi, this quantity 2 theta is making 2 rotations in that amount of time. And that's something we have to account for if we want to find all solutions of this in one full rotation of the theta. So in one full rotation of theta, 2 theta goes around twice. So we have to consider others. So you in fact get this, you have one known answer, and then you have to add, from one position, let me draw it maybe here, if I'm at any angle, I can get back to that angle by going around one full rotation, or 2 full rotations, or 3 full rotations, or 4 full rotations, or really any number n of a full rotation I could go around. So in fact, this n could be negative rotations as well. If I went from this position, instead of going this way again, if I instead went this way clockwise, that's considered negative rotation. And so I would end up getting, possibly negative full rotations as well, leading me to the same point. So, we're actually letting n be in any integer. Integer means these numbers, so 0, 1, 2, 3, and their negatives. Okay, these are called integers. That's the fancy math word for them. So we really have, we have to consider that big infinite class now of solutions. And our job to complete the problem is to, find which n's give us solutions. Which ones are working, which ones give us something that works, it's too big, and so on. Now, our goal in this problem is not to find psi. We found psi. We found infinitely many of them. Our goal should come back to the variable in the original equation. And the variable in the original equation was this theta here. So we have to translate the problem back into theta, okay? So we have to translate back to the theta variable. Okay, so if we do that, we exploit this equation that we had. Okay, psi is 2 theta, so I really have 2 theta equals pi over 3 plus 2. I like 2n pi better for some reason, and 2 theta is 2 pi over 3 plus 2n pi. I don't care if you write 2n pi or 2 pi n; doesn't matter to me. They're the same. And so, well, what am I going to do with this? Well, I'm going to start picking various ones of these integers and see which ones give me solutions. It's that simple. So, with this solution here, I will start picking values of n. Maybe I pick n equals 0 as sort of a... let me maybe separate this into 2 of them. So let's take n equals 0 first, and let's work with the top equation, and then over here we'll do the bottom equation. Okay, because we have to consider both. Now, I guess we need to solve for theta. So let's take the top equation and divide by 2, and you'll get that theta is pi over 6 plus n pi. Now, I'll tell you, it's convenient to get the common denominator here. It's going to make your life easier. So you benefit a lot by writing this as pi plus 6n pi over 6. And you'll see why in a moment. Because once I start picking these n's, if I leave it this way, I have to find a new common denominator pretty much every time. But if I do it this way, I've already got that common denominator. It saves me work. The bottom becomes theta equals pi over 3 plus n pi, which if I got a common denominator would be pi plus 3n pi over 3. So these things on the bottom are what I'm going to be using for these problems. So this one is on this side and this one is on this side. Okay, so at n equals 0, I get theta equals pi plus, and now if I put n equals 0 here, I'll get 0, okay? So pi plus 0 over 6, or in other words, pi over 6. Now the question is, I have this restriction in this problem that 0 is less than theta is less than 2 pi. How does that restriction translate into something over 6? Well, if I divide everything by 6, theta... Oh, sorry, I don't divide by 6. I just write 2 pi as something over 6, and it's in fact 12 pi over 6. My apologies. And over here I have something in terms of thirds. So it's also the same to say it's 6 pi over 3. So as long as this numerator is smaller than 12 here, we're okay. So let's try a bigger n. If I try n equal 1, what happens? Well, I end up with, I guess I can pull this down now because we're using this equation. If I use n equal 1, I get pi plus 6 pi over 6. Well, that's 7 pi over 6. And that is, I guess I put my restriction here. That's well within this range. So, let's see, maybe I'll spread it like this. So that's well within this range. 7 is smaller than 12, so that's okay. If I try n equal 2, though, what happens? Well, I get pi plus, and if I put 2 in here for n, I'll get 12 pi. So I'll get 12 pi over 6. Well, that's 13 pi over 6. I'm no longer in this range. I'm to the right of 12. So that's a bad. And when that happens, everything else is bad. Okay, everything else is beyond the range. Now, you'll recall we allowed integers here. So we also have to consider if n was minus 1, what would happen? So we would end up with pi. We put minus 1 in for n, and we'll get minus 6 pi over 6. And so we end up with minus 5 pi over 6. That's not allowed either, okay, because we got a negative, and all these thetas have to be bigger than 0. So that means that we ended up with these two solutions as good for that equation. Now we have to repeat the same thing for this equation, okay? And I'm going to copy over the condition here from here so that I can bring this back down. So we do the same process. So I start with n equals 0. If I do that, then we end up with theta is pi over 3 because I'm plugging in n equals 0 into this formula. So that's a good point, okay? If I now let n equal 1, then I end up with theta equal pi plus 3 pi over 3. In other words, I get 4 pi over 3. And that's a good solution as well, okay? Because, well, it's smaller than 6 pi over 3. If I set n equal 2, then I end up with pi plus 3 times 2 is 6. So 6 pi over 3. And I end up with 7 pi over 3. Now that's too big, okay? 7's bigger than 6, so that's bad. And so everything else above it is bad. If I try minus 1, then I end up with theta is pi minus 3 pi over 3. In other words, I get minus 2 pi over 3, and that's bad as well because thetas are greater than 0. So we get these two solutions. So in the end, I got 4 solutions to my equation. I got these two, I got these two, and I got these two. So I write them down. So 7 pi over 6, pi over 6, 4 pi over 3, and pi over 3. And that's the answer. Now, that's significantly more complicated than we had done before, but you have that, okay? You have that.